Hello, this is Darren Pulsipher, Chief Solution Architect of Public Sector at Intel, and welcome to Embracing Digital Transformation, where we investigate effective change leveraging people, process, and technology. On today's episode, we're going to talk about big memory and software-defined memory controllers with Charles Fan, CEO of MemVerge. Hey, Charles, welcome to Embracing Digital Transformation. It's great to have you here.
Hey, Darren, thanks for having me here.
You know, when I heard about your guys' technology, I was blown away. I actually didn't believe it. And then I started playing around with it, talking more to your architects. This is incredible stuff. So you want to tell us how you got here, first off?
Sure. Thank you. And in fact, the reason we are able to do this is because of the technology developed by Intel. Namely the 3D XPoint Optane persistent memory technology. That is really a game changer. And it opened up a whole bunch of possibilities that was not possible before. And I think only building on that foundation that we think we are doing something pretty cool in software on top of that. So happy to go into some details in what we do here.
Well, and of course, being from Intel, I love it when someone takes our technology and makes it even better, right? Yeah, that's always good.
Yeah, the way I see it, we are kind of expressing the power of this new wonderful media that you invented.
Well, cool. So tell me a little bit about why you went in this direction.
Sure. So the technology we are developing is called big memory software. That we are doing this because we believe there is a growing demand from the applications and from the businesses to process data in ever higher volume and ever higher velocity. There are more and more real-time applications that need to really get instant insights and actions from the data that are being processed. And this is calling for a new infrastructure that needs to be more memory centric. And we would like to venture to say more software defined as well. The reason it needs to be more memory centric is because the latency requirement is too quick for a traditional storage architecture to satisfy. Only the memory could have really the microsecond, even nanosecond latency that these application needs. And software-defined, I'll go into more details to see why we think it also needs to be more software-defined. And when we are talking about memory, as more and more software are becoming in-memory or memory-intensive, whether we are looking at AI, machine learning, or real-time big data analytics, or just in-memory databases for transactions, that they typically use DRAM today. And DRAM has a nanosecond level latency, and people are able to deliver pretty nice capability and the capacity of DRAM in today's servers. So that does provide a solution to many of these problems today. However, DRAM does have its limitation. It does have a physics, a limitation in physics in terms of how much the density of the memory and how much you can fit in a server. It's also relatively expensive. That's also a result of the physical density. And very importantly, it is volatile. And volatile may be okay in a small data world because you won't lose small amount of data, but once data become bigger and bigger, that's in the memory, volatility become more and more of a constraint in terms of how you want to protect the data that's running in memory. So today, if you have a few hundred gigabytes in memory, if you crash, it actually takes quite a few minutes or even hours to recover the data that was running in memory. So these are the limitations of DRAM, and persistent memory came out and that changed the game. It basically removed these bottlenecks. You have bigger capacity, you have a lower cost, and you have persistence. So many of the constraints that DRAM poses on the applications are being removed by this new technology. But the technology alone, there are some challenges in terms of how can we move the existing application, the existing workload on top of it. There is it speaks a different API if you want to enjoy all of its benefits, and how do you get existing application to use it without rewrite, because rewriting is great. It can use the hardware, but not everyone's in position to rewrite their app.
Yeah, that's very true. A lot of my customers say, this is the coolest technology, this PMEM, persistent memory, but you're telling me I have to rewrite all my applications. There's no way that's going to happen.
Right. It takes a long time, and sometimes the original developer is no longer here. So
yeah, meaning
so
he's dead. Yeah. Some of us old guys are dying off that wrote code, 30, 40 years ago.
I think both of us have been engineering managers, so we know what that feels like.
Yes.
So there's the compatibility, and then there's the performance. So today, the Optane does operate at memory speed, but in latency, in some of the access patterns, it is a little bit slower than DRAM. So if we don't do anything smart, then there is a hit, 10%, 20%, 30% to a workload, depending on the workload, if you run that on PMEM. And then with persistence, what's the best way of using persistence? That's sort of the least disruption to the programming paradigms as before. So those are also the open questions. As this wonderful magic new hardware come to market, how can we get the application to move on top of it? And that's essentially what we set out to do 3 years ago. That was 2 years before Optane became available as in the memory form factor, but we kind of anticipated there might be interesting value add a software can deliver.
And that's when you guys came up with this software-defined memory.
Yes.
Right?
Yes.
It was brilliant because it fits really well into that whole software-defined infrastructure layer that I've been preaching about for years. And then when I heard you guys had a software-defined memory controller, I was like, whoa, game changer, right? Now I can do crazy things inside my CPU that I couldn't do before. So this is very, very cool.
That's right. I believe, certainly there's a digital transformation that's going on in a lot of the enterprises. And I think to serve that, there is a data center transformation I foresee in the next 10 years. I think it's going to become, from a hardware perspective, perhaps a more heterogeneous world, both from a computing elements point of view and from memory elements point of view. And there will emerge new fabric, such as CXL, that interconnects between these elements. And now the biggest challenge, I believe, is how do you get the application ecosystem to move?
Yeah, that's going to be tough.
On top of this new infrastructure. And I think that's where what you mentioned as a software-defined infrastructure is needed. You need a layer of software to really glue over it and massage it into consumable pieces, composable pieces that are easier for the application to digest. And our software is in that space. Essentially, we are creating an important component, which is a software-defined memory component, to make the memory resources, composable, digestible by the applications in the easiest way.
Yeah, I mean, the things that you bring with that, you bring dynamic SLA and QoS, you bring resiliency, application persistence, efficiency, performance, all the things that you normally get with like software-defined compute, storage, or network, we now get with memory with, like you said, that lower latency and screaming fast speeds.
Yes, exactly.
So very cool.
So on top of that, we did, I think our two most important intellectual property or inventions that we have done. The first one is, a software virtualization layer that optimizes on the performance of this software-defined memory, the combination of PMEM and DRAM that we were able to get it to be very close to the DRAM performance. In fact, for any workload, we can find a ratio between DRAM and PMAP so that the performance is at or
Optimal.
exceed the DRAM level performance. And by offering this as software, we have an unfair advantage because if you configure this in hardware, you have to configure really for the
whole machine.
server,
Yeah.
the whole machine, and it's difficult to change. You have to reboot your machine to change your BIOS to change it. But now we can do it in software, so you can configure different ratios for different applications, and you can dynamically change the ratios as you need it, depending on the workload. So this essentially gives you all the flexibility and power to get the performance and optimization we have done in our tiering algorithm, so we can deliver the sum, the combination of the capacity between DRAM and PMAP, and we have done enough software optimization in the allocation and tiering of the memory to get the performance to be at the DRAM level. So this is really the first of our value add, our technology.
Yeah, when I first saw those performance numbers, when your team showed me them, I was like, how in the world can you be faster than DRAM? Because you have some like SQL performance numbers
right.
that are like, I'm like, this is amazing. And the cool thing that you get with it is not only is it as fast or faster than DRAM, it's persistent.
Right.
So, which is another crazy thing, right?
Right. So that's the second of our two inventions so far, is how do we best to take advantage of the persistence capability of the underlying hardware. So I think the most wonderful properties of Optane persistent memory is that it is persistent, and unlike any memory that came before it. But how to use persistence is not a trivial question. You can certainly have a new API that present a new persistent memory, and then if you're developing a new application, or if you're rewriting an existing application, you write to that new API, then you need to change the way you're thinking about memory as an application developer. Which is great. You can open up new ways of writing a new app. That's wonderful. But most of the applications today are not ready for a redesign, or this is not a simple rewrite of changing an API call. This is a
architectural change.
Right. A programming paradigm change. It's like the way you reason about things.
Because what did they pound into us in computer science schools?
Right.
They said, no, you can't store everything, because once you turn that machine off, all your memory goes away.
Yeah.
That's not true anymore. So all this complexity that we built in marshaling data structures and all that stuff, that goes away. And that's when I saw this technology like 3 years ago with persistent memory, I was like, oh, I got to get my hands on that, because I can get rid of tons of code, middleware. And what you guys are saying is, that's a huge paradigm shift.
Right.
It's going to take a long time for people to get used to that kind of programming.
Right. It's a huge paradigm shift. Everything we learned in the computer science schools in the last
throw it away
70 years going to be thrown out of the window, and there's a new way of doing it, and a better way too. But not everyone can do that on day one. So it's going to be a 10-year, 20-year journey as we're moving into that world. So now the question is, now we see this future, and we are where we are in the present. How do we build a bridge into this future in the most seamless way possible? And we've been working on this problem for over 3 years now. And we believe so far what we have found, the best way to persist, if you don't want to break the existing paradigm, if you don't want to change the existing application, is through a new mechanism we call in-memory snapshot, or zero IO snapshot. So how does that work? Is it works on top of our software-defined memory. So our software-defined memory is a volatile memory service. Even though the underlying DRAM PMAP, the PMAP is persistent, but we're presenting to applications in a DRAM-compatible volatile memory service. And this is so that we don't break the existing application, no rewrite, it would just work out of the box. So so that alone doesn't give you persistence. Now, on top of it, how we leverage the persistence is we provide the operator of the application a GUI and a CLI, so that you can see all the applications that are running on your software-defined memory. And as you mentioned, this is already powerful because you can monitor how things are going. You can define SLAs. You can dynamically refine the ratio to support these applications. But now we add in a snapshot capability. So now you can, for any applications, you can decide to take an instant snapshot of that entire application state. And that's a snapshot. You can recover that application at any time in the future.
Right. To me, that's a game changer right there. Because I got customers right now that they have this box that they've been running on this application. No one knows who wrote it anymore.
Right.
They said, we need to make it highly available, but we don't know how.
Right.
And with this, I can make it highly available because not only can I snapshot it, I can restore it like that.
Exactly. So this makes your memory not only persistent, but highly available. That you can, after crash, you can do an instant recovery to that snapshot of your application. And you can roll back. If there is, if you by accident, we are human, made a mistake in my database, you can roll back to a previous point before that error occurred. And we can do clone on top of the snapshot. So you can create new instance of the application without actually physically replicating the memory. So you can create multiple independent processes and their logical memory spaces mapping to the same physical memory space. And this not only saves memory, this also makes the process of creating clone instant. And at the same time, they are independent instances, independent different processes. So each can run, and you can create new memory, and we do the copy on write. So we kind of manage the forking the different memory pages depending on the different.
So that's incredible, because my brain is now going, whoa, I know what I can do with this, right? I can have tons of microservices, all the same instance, popping up and tearing down almost instantly.
Exactly.
To handle load or whatever I need to do.
Yeah,
This is pretty slick technology.
Right. I think this essentially makes a lot of things that were impossible before possible. And this is really the combination of the hardware innovation that Intel did, with the 3D XPoint, and the software innovation that we are working hard to invent.
Great technology. Like I said, when I saw it, I was like salivating. I'm like, this is so awesome, because I write a lot of little apps to keep my software skills up. People that listen to my podcast know that about me. And now I don't have to worry about persistence. I'm just going to take a little snapshot and then roll back to the testing I was doing before. This is, there's so much possibilities with this.
Yes. And in the future, so this is what we are delivering today. So later this
amazing.
Later this month, and in partnership with Intel, that we will launch the first version of our product for general availability. So this month is a very exciting month for us after more than 3 years of labor, tough labor.
Lots of labor.
That we are delivering the first version of our product to the world. And what I just described, both the software-defined memory and the stereo I/O snapshot capability, are going to be part of this release that we are making this month. But just to give you a sneak preview of the future, I think this snapshot, right now, is from an administrator point of view. That allows you to save the state of the entire application, and this is useful for a number of use cases. We are working with Intel on a number of customers in financial, media, and entertainment, and oil and gas, and other sectors, into using these features. But in the future, we are planning a version 2.0 now in a year's time or so, that will have an SDK. In addition to using it as a transparent memory layer, now for the new application developers, we are going to create a new way of persisting your data. And this will make the new application development easier, as well as make it easier if you want to modify your existing application. So what this is, right now we are offering a DRAM compatible memory service to make your memory bigger, cheaper, persistent, and snapshot and all that. But we are not solving the storage problem per se with version 1. So storage, go to storage,
right?
And now with bigger memory, maybe more stuff can go into memory, configured into memory, but storage we don't touch. But with 2.0, and with the SDK, we think snapshotting is also an interesting new way of persisting data, not for the whole application, but for whatever chunk of data that you want to save. So today, if you are running a database or so on, it runs in memory, and when you need to persist, you sort of serialize it. You
right. Yeah. It takes.
Handle,
Yeah.
You write it in 4K blocks, and then you close it, and so on. And when you read it, you kind of do the reverse.
I looked at that, Charles, and it's like 20 steps.
Right.
To take a data structure and to stream it, to store it. It's 20 steps.
Right. That's why it's so slow. And often you need to go through a network, and not to mention all of that. Right. So that's why storage I/O can often be a bottleneck. So now with the new method, through snapshotting, essentially we have the ability of snapshotting any subregion of memory. So you can write your program. There's no architectural change to your program, but when you need to persist something, you can just snapshot it. That little area, slick. That particular table, particular variable, particular column, or so on. And so this, I think, doesn't change the familiar model of programming, but greatly accelerate the I/O expat, because there's no more I/O. There's
that's incredible. Now tell me a little bit about, if I snapshot something, can I move that to another machine?
Yes.
So I'm not stuck on one machine.
That's right. So essentially, after you create a snapshot, this become a manageable object. The whole snapshot. Right after the snapshot process, which typically takes less than 1 second. Even if you have a terabyte of memory, it takes like less than a second to take a snapshot. And once that's done, this is an object. Now you can decide to move to a storage system if you like, move to another server if you like, and these things can be transportable, and anywhere, anytime, you can restart this application instance from that snapshot object.
So I could, right before I shut down a server, I could snapshot my applications, move the stuff over, turn it back on, and be up. Now your team also said there's live migration available too. Is that right?
Right. So essentially, this can enable certain migration scenarios
gotcha.
That you can capture in a snapshot, move it to another places in the cloud or somewhere, and start your application there. You don't lose anything in this process.
That's really incredible stuff.
Right.
Well, Charles.
So we are very excited.
Yeah, this is exciting stuff. So your launch is in the next 2 or 3 weeks.
Yeah.
September. When's your launch?
September 23rd.
September 23rd.
I think you are the first place we're announcing it.
That's awesome, right?
In the next couple of days, people should start seeing some social media announced preview of our product launch event.
A great technology. Thanks a lot, Charles, for your time today. I only wish you the best, because this is incredible technology.
Thank you, Darren.
Thanks for listening to Embracing Digital Transformation today. If you liked our episode, go ahead and give us 5 stars on your favorite podcast or video streaming site. You can also find out more on embracingdigital.com. Until next time, keep moving forward and embrace the digital revolution.